So here is an example. Show that the curve with this equation has an unstationary point of inflection at x is equals to 2. Now, the first step is to find the first and the second derivatives. So step 1, we need to find the first and the second derivatives. So the first derivative will be 4x cubed minus 12x squared, and the second derivative will be 12x squared minus 24x. Okay, so we have the first and second derivative. What next? Step 2, we need to set the second derivative equal to 0 and solve for the potential inflection points. So step 2, we set the second derivative equal to 0 and solve for the potential inflection points. It could be points, could be 2 points, we don't know. We need to figure it out. So we are going to equate the second derivative to 0. So 12x squared minus 24x is equals to 0. We can factorize out 12x, so that will be x minus 2 is equals to 0, which implies that either 12x is equals to 0 or x minus 2 is equals to 0. So either x is equals to 0 or x is equal to 2, which means we have two potential inflection points. So what do we do next? We are going to use a sign diagram for the second derivative to check for change in concavity around these potential inflection points. So step 3 will be use a sign diagram for the second derivative to check for change in concavity around the potential inflection point. So, which means we need to draw a sign diagram like that one. We have 2 points, 0 and 2. These are x values. Now, what we need is the signs for the second derivative, which means we are going to pick some test points in between these guys here and try them out. For example, we can test the point on the left of 0, which is -1. Here we can test the point between 1 and 2, 0 and 2, which is 1. Here we can on the right of 2, 3. That will be fine. So, and we are plugging these values into the second derivative, into that guy. So, and we want to find out what do we get. And they're just interested with the signs. Anyway, that will be 36, that will be -12, and that will be 36, which means we have positive, negative, and positive. So there's change in signs, which means concavity changes. So which means we can say that concavity changes at x is equals to 0 and at x is equals to 2. Okay? So hence, that means that this function has 2 points of inflection, 2 inflection points. So this function has 2 inflection points, and we need to figure out, remember, from the question, we need to figure out non-stationary point. Well, which means maybe having 2 non-stationary points or something else. We need to figure it out. So which leads us to step 4. So step 4 is to use the first derivative to determine if they are stationary or non-stationary points of inflection. So step 4, use the first derivative to determine if they are stationary or non-stationary points of inflection. Okay, so we need to use the first derivative to determine if they are stationary or non-stationary points of inflection, which means we need to plug these guys into the first derivative. Okay, so we're going to plug in 0, see what happens. Plug in 2, because the points are, the x values are 0 and 2. So you plug into the first derivative, that guy, see what happens. So if you plug in 0, you end up with 0. If you plug in 2, you end up with negative 16. So what does this mean? It means that a stationary point of inflection occurs at x equals to 0. So stationary point of inflection at x is equals to 0. And what does the second one mean? Because the first derivative is not equal to 0, it means that an unstationary point of inflection occurs at x equals to 2. So non-stationary point of inflection at x is equals to 2. So are we done yet? No. We need to find the point. So the point means we need to find also the y coordinate. So which means we need to go back here and move to step 5. So step 5 will be finding the y coordinate. Okay. So our step 5 is to find the y coordinate. Okay, so we find the y coordinate, which means, and by the way, here we're just interested in the stationary, non-stationary point of inflection, which means we are interested in this point here. Okay, so we are just going to plug in 2 because we want the non-stationary point of inflection. So if you plug 2 into the original function, what do you end up with? If you plug 2 in the original function, you'll end up with negative 16. Okay, which means that the non-stationary point of inflection is 2, negative 16. Okay, is 2, negative 16.